Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat malam dan selamat datang ke kelas tuisyen online percuma yang dibawakan oleh anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan E-Didik Malaysia. Bermula percuma, selamanya percuma. So ini adalah kelas tuisyen percuma bagi subjek Fizik SPM untuk tingkatan 5. Tajuk kita pada malam ini iaitu 3.3 3.3 E.M.F and internal resistance. Okey, apa khabar anak-anak pelajar, anak-anak murid di luar sana? Cikgu doakan di mana jua anda berada, anda sentiasa berada dalam keadaan sihat walafiat. Okey, baiklah. Sebelum kita memulakan kelas pada petang ini, bagi yang beragama Islam, ayo kita mulakan dengan umul kita Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okay, so kita ada Jimmy di sana. Hello Jimmy. Thank you for joining us and welcome to teachers class. Jadi saya perkenalkan diri terlebih dahulu. Bagi yang pertama kali mengikuti kelas ini, saya ialah Cikgu Hasnitah. Dari SMK Bagan Jaya, Butterworth, Pulau Pinang. Okey, saya bersendirian saja di konti pada malam ini. Jadi anda boleh lihat pada pin message, cikgu ada kongsikan pautan untuk modul yang cikgu guna pada malam ini. Anda boleh download dan cetak keluar untuk rujukan anda. Okay, so you can have your own PDF slide copy, print them out and you can use them along with this lesson. Anda boleh tonton dulu kelas ini, boleh muat turun kemudian dan boleh tengok semula video ini untuk mendapatkan jawapan yang penuh. Alright, okay, so tanpa membuang masa lagi, mari kita mulakan kelas pada malam ini. Cikgu perkenalkan dulu barisan guru-guru fizik yang ada di Akademi Youtuber. Seperti yang anda lihat pada skrin, walaupun ada di antara guru-guru berikut yang tidak lagi bersama dengan kita, tapi untuk kelas tuisyen percuma, kita masih teruskan dengan Cikgu Izyan di sana dan kita ada Cikgu Rosemawati berserta dengan teacher SlindaNordin untuk kelas tingkatan 4 setiap hari Jumaat 9.30 malam. Dan untuk tingkatan 5 bagi kelas DLP, saya sendiri dibantu oleh Mr. P. Okey, jadi minggu depan anda akan bersama-sama dengan Mr. P untuk tajuk yang seterusnya 3.4 3.4 Electrical Energy and Power. Okey, jadi kepada siapa yang belum lagi memuat turun aplikasi Akademi Youtuber di Android anda boleh berbuat demikian hari ini. Apa yang ada pada apps ini, anda muat turun di mana? Di Google Play Store. Okay, di sini kita ada lebih daripada 26,000 video PDPC daripada prasekolah hinggalah ke pra-universiti yang anda boleh manfaatkan. Okay, semoga video-video ini membantu anda dalam mempelajari topik-topik yang ada di sekolah. Okay, so student, without further ado, can you give me some response? Either you can hear me clearly or not. If you can hear me clearly, can you type clear teacher? Alright, okay. Cikgu Kok belum lagi bersedia untuk live bersama kita, tapi mungkin beliau ada live di channel sendiri untuk subjek sains ataupun fizik. Okey. Jaya boleh dengar cikgu dengan jelas. So students, for this topic 3.4 electromotive force and internal resistance. It is discussed in our textbook, started from page 114 until page 123. Okay, clear. Thank you. Terima kasih. Okay, siapa yang ada bersama kita boleh juga perkenalkan diri. Okay, thank you Jimmy for your response. Okay, so this will be our learning standard for tonight. Okay, there are 4 learning standard where after discussion, I hope each and every one of you will know how to define electromotive force. Second, to explain internal resistance. And third, to conduct experiment to determine E.M.F and internal resistance in a dry cell. So this one, I believe you have conducted with your teacher in school. And last but not least is to solve problem involving E.M.F and internal resistance in dry cell. So later student, we will try to do a few example of questions related to this topic on E.M.F and internal resistance as well. Alright. Okay, so let us begin with the first learning standard. Okay, if you are ready and good to go, and please make yourself comfortable there. So this is our first learning standard to define what is E.M.F. Okay, students I believe you have learned this in school. So this can be as a revisions, okay, for your incoming trial SPM for physics. Okay, can someone share what do you understand by E.M.F? Jimmy, maybe? What is E.M.F? Electromotive force. Okay, or Chaya, you can give a try as well. Okay, so this is the diagram. Okay, as to bring your understanding to E.M.F. Okay, if you look at this diagram, you can see on the left, yes, there is a torchlight. Okay, and on the right side, we have a simple circuit connecting a dry cell, bulb, and switch. All right. So if you look at these two diagrams, on the right, when the switch is closed, okay, so now this switch in closed position, so we say that the circuit is complete. Okay, circuit is complete, and you can see that the bulbs light up. Okay, so we understand when the switch is closed, the circuit is complete, so there is current flow in the circuit. So the current, the flow of current actually indicates the flow of charges. You learned before in 3.1 student. Jimmy say DGE, diagram electric. Yes, this is in Bahasa Melayu. Okay, so but what is DGE or E.M.F actually means? Okay, so there is one question for you to, okay, you can ask here, what caused the charges flow in the electric circuit class? Who drive the charge so they flow along electric circuit? Okay, so let us take a look at the next slide. Okay, so for this one, so to understand how charges able to flow through a circuit, so you can look at these two GIF on top and at the bottom. Okay, number one, battery. Okay, so I believe everyone know what battery is. So battery is a source of electrical energy which move charges around the circuit. If you see just now, the circuit is connected to a battery. Okay, so how this battery, students, give electrical energy to the circuit? So battery convert. Okay, inside battery we have electrolyte. Okay, so it convert chemical energy stored in the electrolyte to electrical energy. So this is the energy changes that occur when a battery is operating. It convert chemical energy into electrical energy. All right. Okay, then what happened next? So this energy, okay, is used to move 1 coulomb of charge in the circuit. So if you look at the GIF down here, okay, you can see that initially we have an old man. Okay, an old man, once they enter this chamber, which is a battery, then they will be recharged. So they come out as a young man, okay, full of energy. So they can work all day long. All right. So the old man represent charges. So when the charges pass through a battery, it will receive energy from the battery. So it can move along the circuit. As written here, each 1 coulomb of charge that flow through the battery will receive electrical potential energy so that they can move in the circuit. So therefore, we say that the work is done by the battery in driving the charges around a complete circuit. And the work done is known as EMF. So if I ask you what is EMF, so EMF is defined as the work done. Okay, kerja yang dilakukan oleh sumber tenaga elektrik untuk menggerakkan satu coulomb charge mengelilingi satu litar yang lengkap. Okay, di sepanjang litar yang lengkap. So what is EMF? It is defined as a work done. Okay, a work done by an electrical source, which is a battery, to move 1 coulomb of charge around a complete circuit. Alright, so this is the definition for EMF, our first learning standard. So if they ask you what is EMF, you must know how to write. It is work done by electrical source to move 1 coulomb of charge around a complete circuit. Okay, and this is the formula for EMF, students. So EMF with the symbol of epsilon equal to E. E is energy or work done, divide by Q, where Q is a charge. So according to this formula, we write the SI unit for EMF in joule per coulomb, or normally written in volt, capital V. Yes, Jimmy, volt is the unit for EMF. Alright, okay, next, student. So the first activity is to compare between EMF and potential difference. You learn potential difference before. Okay, energy used or work done to move charges across 2 points in an electrical circuit. Okay, so we also have Mr. Pei there. Thank you very much for supporting us, Mr. Pei. Thank you for joining our class this evening. All right, student. So this is the first activity to compare EMF and potential difference. Okay, if you look at this circuit, okay, this is the electrical circuit to study EMF, and this is the schematic circuit or the circuit diagram. All right, okay, so initially if you look the switch, okay, the diagram on the right is also the same diagram. Okay, voltmeter connecting parallel to the battery. If you want to study EMF, the voltmeter must be connected parallel to the sources of energy, which is the battery. So this is the switch. We have a bulb there connected to the ammeter to measure the flow of current in the circuit. Okay, so what happens, student, when we close this switch? Okay, so number one, you will observe what happened to the light bulb, and second, to observe the reading on the ammeter and the voltmeter. All right, okay. So let's say, students, this is the result. Okay, we gain or obtain from this activity. So if you look at the diagram on the left, so this is the reading of the ammeter when the circuit is open. Open means the switch is off. Okay, the switch is off. Okay, so no current flow. So you can see the ammeter reading is 0. Okay, and then this is the condition when we close the switch or the switch is on. So you can see there is a reading on the ammeter showing that current is flow through the circuit. Okay, while down here, this is the reading of voltmeter when the circuit is open. It readily shows a reading of 3 volt. So what is this reading refers to? And then when we close the circuit or we on the switch, you can see that the reading of the voltmeter decreases. Okay, become 2.7 volt. So why there is a difference of reading on ammeter and voltmeter? So first and foremost, we complete this table. Okay, so let's say this is the reading we determine. So when the switch is open, the bulb is light off. Okay, so we understand no current is flowing because the circuit is incomplete. Okay, and the ammeter reading 0, but the voltmeter show reading 3 volt. So what is this 3 volt refers to? Yes, very good. This is the EMF of the battery. Okay, then student, when we close the switch, so you can see now the bulb light up. Okay, it light up mean current flow through the circuit with a 0.2 ampere, but now the voltmeter reading dropped to 2.7. Okay, so actually this 2.7 refers to potential difference across the bulb, okay, when the switch is closed. While 3 volt is the reading of the E.M.F when the circuit is open. Okay, so I hope you can differentiate what is this 3 volt and 2.7 volt refers to. All right. Okay, next. So from this simple activity, first, what is the change is in energy when the bulb light up? So we can say that electrical energy convert to light energy and heat energy. Okay. And then what is the quantity of electrical energy released by the bulb for 1 coulomb of charge that flow through it? Okay, how to answer this, student? Question number 2 refers to the potential difference. Okay, so what is the quantity of electrical energy released by the bulb for 1 coulomb of charge that flow through it? So when 1 coulomb of charge pass through the bulb, it use 2.7 joule of energy. And the third question refers to E.M.F. Okay, what is the quantity of electrical energy required to move 1 coulomb of charge through dry cell? So again, this is referred to the E.M.F, which is 3.0 joule of energy. All right, so I hope you are clear, understand activity 1, how to differentiate E.M.F and potential difference. So again, this table show to you the comparison between E.M.F and potential difference. Okay, E.M.F is the voltmeter reading when the switch is open or off. Okay, while potential difference is the reading on the voltmeter when the circuit is closed or when the switch is on. All right, and E.M.F used to the energy supplied by the battery. Okay, meanwhile, potential difference refers to electrical component as a circuit such as motor or a light bulb. Okay, energy used when current pass through a motor or light bulb or any electrical appliances. Okay, and third, E.M.F is the electrical energy transfer when 1 coulomb of charge flow through a complete circuit. And potential difference is the electrical energy transfer from one point to another in an electrical circuit across a conductor. All right, but they have the same unit of joule per coulomb or volt. So are you clear with the differences or comparison between E.M.F and potential difference? If you do, you can give me some response by typing yes in the live chat. Kalau anda faham perbezaan E.M.F dan potential difference, boleh type yes pada live chat. Alright, okay students. So I believe you used to see this. This is one example of a dry cell or a battery. You can see there is a label on this battery, 1.5 volt. So can you tell me what is this label refers to, students? Yes, very good. This label refers to the E.M.F of the battery. So it written there 1.5 volts. So it means, yes, this cell give 1.5 joule of electrical energy to each 1 coulomb of charge that pass through it. Okay, I repeat, this battery give, okay, 1.5 joule of energy for each 1 coulomb of charge that pass through it. All right? Okay. Okay, next. Okay, done with the first learning standard. We have defined what is E.M.F. Okay. So, what is E.M.F again? Jimmy, Putri Alia, Assalamualaikum, and welcome to our class. So, we have done with the first learning standard on how to define E.M.F. So, again, student, E.M.F is the work done. Okay. Work done to move 1 coulomb. Work done by who? Work done by a sources of energy in moving 1 coulomb of charge around a complete circuit. Yes, okay. So next, let us continue with the second learning standard. Before that, I would like to remind you again, I have put on the pin messages the PDF copy for students module, okay, which is in accordance to my slide. So you can use them as your reference. Can download and print them out all for free. Boleh cetak keluar percuma saja dan jadikan sebagai simpanan bahan ulang kaji anda. Alright. Okay, next student. Now let us talk about internal resistance. Okay, in our second learning standard. Okay, so to understand internal resistance, this is the activity related to it. Okay, activity 2 is to study effect of internal resistance on voltage drop. So this is all the apparatus required for this experiment. So we are using two types of dry cell that with a different brand, okay, Duracell and Energizer, for example. So this is the procedure from number 1 to number 5. Okay, so this is the setup of apparatus. Again, the voltmeter must be connected to the dry cell if you want to study E.M.F or internal resistance of the cell. All right, okay. So students, let's say this is the come out from this activity. Okay, we are comparing Duracell and Energizer. Okay, so first, before we begin, we must use a new battery. Okay, new Energizer, new Duracell. Why? Why must use new dry cell? To make sure that the E.M.F for both are 1.5 volt. Okay, so we must begin with the battery with the same E.M.F 1.5 volt. So you have to use a new battery, not an old one, because when we use the battery for longer time, definitely the E.M.F will be decreases. Okay, and it can be drained out as well. Okay, so let's say this is the table of result we gain from this activity. So earlier they have same E.M.F, both with 1.5 volt. All right. Okay, and this is the voltmeter reading after the switch is closed. Okay, 1.4 for Duracell and 1.3 for Energizer. All right. Okay, so you can see there's a difference there, 1.4 and 1.3. So from here, can you find the voltage drop in both battery? Okay, so what is the voltage drop? So what is voltage drop? Voltmeter reading after the switch is closed. So 0.1 voltage drop for Duracell and 0.2 volt voltage drop for Energizer. So you can see that Energizer has a bigger voltage drop compared to Duracell. So from here we say Energizer, question number 2, experience greater voltage drop. Okay, and the third question, they ask you why there is a difference in voltage drop. So why do you think the voltage drop is different between these two dry cell? What caused the difference in voltage drop, even though they have the same E.M.F? Can you think the reason? If you do, you can share your answer in the live chat. Student, why do you think there is a difference in voltage drop for both batteries? 0.1 for Duracell and 0.2 for Energizer. Anyone would like to give a try? Okay, yeah. Okay, so the difference is actually due to the internal resistance in the dry cell. Okay. Since we have different brands, so they normally have a different type of electrolyte used inside, different chemical used as an electrolyte. So due to this different of electrolyte can have a different internal resistance. So this is the factor affect the voltage drop in both batteries. So it's written there, a cell with high internal resistance will have higher voltage drop. So from here we understand Energizer has a higher internal resistance compared to the other dry cell, which is Duracell. Alright? Okay, next. Okay, now, so what is meant by internal resistance, students? Internal resistance of a dry cell is defined as the resistance which is caused by the electrolyte in the dry cell. Alright, and the unit for internal resistance is ohm, okay, with the symbol omega. So what is the effect of this internal resistance to the battery? Number one, it will cause loss of energy, okay, in a dry cell. Okay. Second, it will cause the potential difference across the dry cell terminal to be less than the E.M.F. Okay, that's why you see from the reading, the potential difference across the dry cell is always lower than the E.M.F because of the existence of this internal resistance from the electrolyte inside the dry cell. Okay, so are you clear? Internal resistance, what does it refers to? Okay, very good. Okay, next student. So this is the equation, relates E.M.F, internal resistance, and voltage drop. Okay, so first you must understand, okay, work done in driving 1 coulomb of charge around a complete circuit. So this is referred to E.M.F. So here we have E equal to the work done in driving 1 coulomb of charge in the external circuit. External circuit mean around the conductor or around the circuit, plus work done in driving 1 coulomb of charge in the internal circuit. So when we plus this, E.M.F E equal to potential difference V plus voltage drop due to internal resistance R. Okay, so what will be the formula if you look from this diagram? Okay, so this is the mathematical formula to relate E.M.F, potential difference, current, and internal resistance. Okay, where E equal V plus IR. Okay, students. So, this is another expression. You can write E.M.F, V, I, and R. Okay, E equals IR. V can be written as IR. Okay, plus IR. Yes, correct, Jimmy. Okay, so you can put the I outside and put R and R at the bracket. Capital R is the external resistor. Okay, external resistance across a conductor, while small r is the internal resistance from the battery. So later we will take a look at a few example of question on how to apply this equation. All right. Okay, next student. Okay, so I think let us take a short break for a while before we continue with the third and fourth learning standard. So don't go away. I will be back after this short commercial. All right, students, so welcome back to our class. For those who are just joining us, I'm Cikgu Hasnitah from Akademi Youtuber, now teaching in SMK Baganjaya, Butterworth, Pulau Pinang. So this is physics online, free online tuition brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia and EDD Malaysia. Bermula percuma, selamanya percuma. Okay, so let us continue with our third learning standard on how to conduct experiment to determine E.M.F and internal resistance in a dry cell. So have you conduct this experiment in school? Can you give me some response? Mungkin ada yang sudah buat, ada yang belum sempat lagi because we are now chasing for the syllabus to prepare you for your incoming trial exam. Okay. As for me, I didn't conduct it yet with my students. Okay, we'll prepare after the trial. All right. Okay. So, student, I will show you one example of experiment normally conducted in school. All right. Okay, so this is in your textbook. This is experiment 3.5 to determine E.M.F and internal resistance. So all the apparatus needed are as listed. All right, and this is the procedure from number 1 to number 5. The diagram of apparatus. Okay, Jimmy said done. Okay, very good. So I believe you don't have any problems on understanding this. Okay, can you share to us which school you are from, Jimmy? Okay, so first you have to connect the circuit as shown in the diagram. Turn on the switch. Okay, adjust the rheostat until the ammeter reading gives 0.2. Okay, then we record the reading of the voltmeter and we repeat the experiment with a different value of current 0.3, 0.4, 0.5 and 0.6. Then finally we plot a graph of V against I. Okay, to analyze our result. Okay, then students. Okay, this is one example of videos. So you can have a look at them first.
So batteries provide an E.M.F, that's electromotive force. You can think of that as the side of it. Hook up a battery to current flow through the battery. We want an ammeter, variable resistance, it's going to be the same setup. I'm going to get my...
So this is how we adjust the rheostat to get a different value of current in this experiment.
Exactly 0.10 amps. There you go, precise. So now that I have my current, I then want to measure the terminal PD. The terminal PD is the voltage available to the circuit. So even though the battery says 6 volts, there's not going to be 6 volts available to the circuit because some of that is being lost in the battery. Sure enough, my voltmeter doesn't say 6 volts, it says 5.53 volts. That shows that some of the 6 volts E.M.F from the battery is being lost in the battery. So we have a terminal PD of less than 6 volts. Let's increase the current by reducing the resistance in the circuit battery. I'm just going to get my PDs for more of the E.M.F lost in the battery. I'm just going to get my PDs for 0.30, 0.40, 0.50. The terminal PD goes down.
Okay, so this is the reading he determined from this experiment. You can see that when the current increases, the terminal or the potential difference is decreases from 5.63 down to 4.87. And this is the graph determined from this experiment, a graph of V against I. All right. So it is a straight line graph with negative gradient. Yes. Okay, so this is the formula I show you just now. The E.M.F is the voltage, okay, plus the voltage loss due to the internal resistance of the battery. Okay, so I think we've done with the video. So let us check a look at the next slide. Okay, so similar to the result gained from the video, so you can see clearly when the current increases, the reading on the voltmeter decreases. Okay, from 2.85 when current 0.2 ampere, drop to 2.4 volt when the current is 0.6 ampere. And this is the graph plotted from this result. We plot the graph of V on the y-axis against current at the x-axis. So remember, student, when you are plotting a graph, don't forget to write the symbol for the quantity, which is V, together with this unit, which is volt. Okay, and here the symbol for the quantity current is I with the unit of ampere. So this is very crucial when you are plotting a graph. And the scale using must be even and uniform. So you plot exactly at the right point. So this is the pattern of the graph we obtain. Okay, again, it is a straight line graph with a negative gradient. All right. Okay. Okay, so students, from this graph, what can we analyze? Okay, number one, okay, what can you say about the relationship between potential difference across the cell and the current flow? Okay, can you respond to this question? What is the relationship of V and I according to this graph? Anyone? What is the relationship of V and I according to the graph plotted here? Okay, so you must know how to read relationship from a graph plotted. You've learned the basic in Form 4. Remember the very first chapter, 1.2, scientific investigation. Yes, so we can say that the higher the current, the lower the voltage. Or you can say the voltage decreases linearly with the current. Okay, the voltage decrease linearly, or the potential difference decreases linearly with the current. That is another answer you can write here. The voltage or the potential difference decreases linearly with the current. All right. Okay. Then second, by comparing this equation, V equals E minus IR with this straight line equation, Y equal to mx plus C, can you determine what is the value represented by the gradient of the graph, and also what is the value represented by the y-intercept? Okay, so from this formula, we understand V represent, okay, this, okay. Then E is the y-intercept, student. E is the y-intercept. Okay. So by this means R is the gradient of the graph. So from here we understand the gradient of the graph represent the electromotive force or EMF of the cell. Alright, the gradient represent internal resistance while the y-intercept represent EMF. Okay, can you see my slide now? I think we have some internet connection problem here. Okay, negative R is the gradient, which is the internal resistance. Correct, Jimmy? Okay. Okay, next, students. Okay. So this third activity is to study the effect of connecting dry cell in series and parallel arrangement, okay, on E, V, R, and I. Right? Okay. So if you look at diagram 3.29 and diagram 3.30, what is the difference between these two diagrams? On the diagram on top, you can see that there are two dry cells connected in series. Okay, so given the EMF there is 3 volt. Okay, while the diagram on 3.3, we have 4 dry cells there, both connected in series, and then they are connected in parallel. All right, and the EMF also given as 3 volt. Okay, then from this example of result obtained for this activity, you can see that both diagram has the same value of EMF of 3 volt. While this is the potential difference recorded when we switch on the circuit. 2.7 for dry cell in series and 2.9 for dry cell in parallel. Yes. And this is the reading of the ammeter recorded by both 0.5 ampere for dry cell connected in series and 0.6 for dry cell connected in parallel. All right. Okay, and this is the effective internal resistance calculated on both. It is 0.6 ohm for dry cell in series and 0.17 ohm for dry cell in parallel. How we determine from this formula? E equal V plus IR. Alright? Okay. So from this example of result, so can you respond which arrangement of dry cell produce smaller effective resistance? Okay. So from here we can see that the arrangement in parallel produce smaller effective internal resistance of 0.17 ohm. Okay, so the current flow in the circuit will be greater 0.6 ampere compared to that in the dry cell in series. All right. Okay, then the third question, student, from this graph again, can you determine the value of EMF shown on the graph? Okay, and how we determine this value? Okay, so again, if you understand, we determine EMF from the y-intercept of V against I graph. So answer is 3.0 volt. Okay, while for the internal resistance of the battery, yes, it is determined by the gradient of the graph. So by calculation, this is the 2 point we can take to measure the gradient. And by calculations of y2 minus y1 divide x2 minus x1, the gradient is 1 ohm. Okay, so the internal resistance of the battery equal to 1 ohm. All right. Okay, next. So this table shows to you the effect of connecting a dry cell in series and in parallel arrangement. So the first GIF, the dry cell connected in series, we have 3 volt and 3 volt there connected in series. So the total EMF will be 6 volt. Okay, while for the GIF below, we have a battery with a dry cell with 3 volt and 3 volt connected in parallel. So this gives EMF of 3 volt. All right. So another comparison, you can see first the diagram of arrangement. This is the effective internal resistance for series and effective internal resistance for parallel. So the advantages for series connection, it will increase the effective EMF. Okay, the EMF will be largest. While the advantages for dry cell in parallel, it will reduces the effective internal resistance in the circuit. All right. Okay. Okay, so now let us move to our fourth learning standard. It's the solve problem involving EMF and internal resistance. So I hope you can ready with your calculator. So we try to solve all the questions together. All right. So we begin with the first question on objective. Okay, can you find which one is the correct answer for EMF? What is electromotive force, student? Is it A, work done by a charge in a circuit? Or B, work done by 1 coulomb of charge in a circuit? Or is it C, the work done by a source of energy in driving a charge around a complete circuit? Or is it D, work done by a source of energy in driving 1 coulomb of charge in a complete circuit? So which one is the best answer to define electromotive force? For question 1, A, B, C, or D? Which one? Yeah, very good. So the answer is yes, donkey. Okay, the work done by a source of energy in driving 1 coulomb of charge in a complete circuit. Yes. Okay, so now let's move to the next question. Yes, good, Jimmy. Answer B is donkey. Jimmy, read the question carefully. Answer is donkey. Okay, next. Which circuit can be used to determine EMF of a battery? Student, this is SPM 2005 question. So you study the circuit carefully. which connection is correct for us to determine E.M.F. Remember, I mentioned just now, if you want to study E.M.F and internal resistance, the voltmeter must be connected parallel to the dry cell. So which diagram, which answer shows that connection? Is it A, B, C, or D? The keyword is the voltmeter must be connected parallel to the dry cell. Not to the bulb, not to the conductor, parallel to the dry cell. So answer is, okay, you can have a look at all answer A, B, C, and D. So which one? Remember again, Jimmy, the tips is the voltmeter must be connected parallel to the dry cell, not to the bulb or not to the resistor. Is it A? Really? So answer will be C. Answer will be C. You can see that the voltmeter here is connected parallel to the dry cell. Okay, then only we can determine the E.M.F and internal resistance of the battery. For A connection, for this arrangement, this is to study Ohm's law. Okay, to study the factor effect resistance in a conductor. Okay, that is the difference between A and C. Okay, next, the third question. Okay, which of the following graph relates reading of ammeter and voltmeter in below figure? Okay, so this is the keyword for this figure. If you look carefully, now the voltmeter connected parallel to the dry cell. So you must understand, this is the setup for us to study E.M.F and internal resistance of battery. So which graph, which is the correct graph for us to study E.M.F and internal resistance of a battery? Is it A, B, C, or D, students? So remember, it is a VI graph, straight line with negative gradient. It must be a straight line graph with negative gradient. Okay, now correct, Jimmy. Answer is donkey. Yes, very good. Okay. Okay, next, student. Question number 5. Okay, question number 5. I'm sorry, question number 4 is missing. Okay, so now we have E.M.F and internal resistance of a dry cell given 1.5 volt and 0.5 ohm respectively. So 1.5 is the E.M.F, 0.5 is the internal resistance. So the question is very simple, nothing to calculate here. What are the reading of the voltmeter when the switch is closed, student? Okay, now the switch is open. Okay, the voltmeter read 1.5. So when we close this switch, mean the switch is turned on. So what will happen to the reading of the voltmeter? Is it equal to 1.5, no changes, or will it be less than 1.5 or more than 1.5? So which one? So if you understand from the discussion earlier, answer should be yes. Okay, when the circuit is closed, the reading of the voltmeter must be less than the E.M.F. So answer is boy, less than 1.5 volt. Okay, all right. Okay, and question number 6. Okay, here you have to make some calculation. This question refer to SPM 2010. All right, we have a cell with E.M.F 1.5 volt. When connected to an external resistor, so potential difference is 1.3 volt. So we have two value there. So you must understand 1.5 refer to E.M.F and 1.3 refers to the potential difference. Yes, very good. Right? So the current flow is 0.2 ampere. So this is I, 0.2 ampere. So the question is, what is the value of the internal resistance? So you can use this formula, find the value for internal resistance. Okay. So I give you a few seconds so for you to find the solution. Then you can say your answer. Is it A, 0.2, B, 1.0, C 6.5, or D 7.5 ohm. Okay, before that, this is the given information can help you to solve the problem. EMF 1.5 volt, potential difference 1.3 volt, current 0.2, and we are looking for internal resistance. So what equation can relate all four? Yeah, this is the equation applicable for question 6. Okay, so have you all find the answer? Putri Alia, what is your answer for 6? Yeah, when you rearrange, this will be the formula. R equal E divide. Is it? Okay. So is it A, B, C, or D, students? So we have to find the internal resistance when given the EMF 1.5, potential difference 1.3, and current flow 0.2 ampere. Okay, so I show you the solution. So later you can compare your answer with mine. So this is the formula, E equal V plus IR. So given E 1.5, the EMF, the potential difference 1.3, current 0.2, R. Okay, so R will be 1.5 minus 1.3 divide 0.2. Okay, so our answer equal 1 ohm. Okay, so answer is B, boy, 1.0 ohm. Did you get the same answer, students, for number 6? Okay. Okay, very good. Okay, now let's move to number 7. You are given this diagram, circuit diagram, shows the switch there in open position. There is a resistor with 2 ohm, ammeter, voltmeter connected to the dry cell. Okay, given that, it say that when the switch is off mean now open. Though the voltmeter reading 9 volt. So this 9 volt is, yes, the EMF of the dry cell. Find the ammeter reading when the switch is now on. So ammeter reading means we have to find the current flow in the circuit when the switch is on or close. On means switch close. We connect. So the circuit is complete, current flowing. So definitely the voltmeter reading will be less than 9 volts. So find the ammeter reading, students. So how to do this question? Again, this is all the given information as your guidance. So you're now given with EMF 9 volt, internal resistance 1 ohm, external resistance of the battery 2 ohm. Okay. So now they don't give you V. So you can write V in terms of IR. Okay. So this is the formula applicable for question 6. E equal IR plus R. Alright. Okay. So you just do the substitution. 9 for the EMF. Current we are looking for. External resistance from the bulb 2 ohm. Internal resistance of the dry cell 1 ohm. So by this, current is, yes, 3 ampere. Current is 3 ampere. Simple, right? Okay, very good. Okay, next, let us try some structure question. Okay, this is also similar to past year SPM question, but I don't remember which year, what is the exact year. So you can see that there is a graph of V against I. Show the result of experiment to determine EMF and internal resistance of a dry cell. Okay, so this is the graph we are given in this diagram. Okay, first question, student. Based on this graph, what happened to V when I increases? Okay, so just one word, the answer. You write the answer just in one word. What happened to V when I increases? What happened to the potential difference when the current increases? Okay, any answer? Yeah, 3 ampere is the answer for the previous question. Very good. Okay, so what happened to V when I increases, students? So one answer there. Yes, very good. It is decreases. So from this graph, you understand when current increases, the voltage will be decreases. Okay, determine value of potential difference when current 0 ampere. Find V when current 0 ampere. Okay, so now you have to look when current 0 ampere, 0 ampere here. Okay, so what is the value for V, student? Now can you see V? So the line is not connecting to the y-intercept, right? Which means we must do a graph extrapolation first to find the answer. So how we do graph extrapolation? So you extend this line until it passes through the y-intercept. Okay. So now can you see the value when current 0? So V is 1.5 volt. Okay, so this is the answer, 1.5 volt. So the method we are using is extrapolation of graph. All right. Okay, then third question. Name the physical quantity represent the value in A2. So this 1.5 represent what, student? Okay, y-intercept. Okay, 1.5 is the y-intercept. It represent what? Yes, very good. It represents the E.M.F of the dry cell. All right. Okay, now in question B, you have to find the internal resistance. Okay, given that internal resistance is given by the negative of the gradient. So how to find gradient? Very simple. You just have to find any 2 points along this line and draw your triangle for gradient. Okay. Now you can calculate the gradient by taking these 2 points, the first point at this end and another one at this end. So using y2 minus y1, divide x2 minus x1. So we will have 0.48 ohm. This is the gradient which represent the internal resistance of the dry cell, 0.48 ohm. Clear? Okay, very good. Okay, now last question. C. From the graph, state the value of V when I 0.8 ampere. So find potential difference when current 0.8 ampere. So if you look again, this is where current 0.8. Okay, so how to find the potential difference when the current is 0.8? So how we do? So this is how we do. You can draw straight line from the current 0.8 until the line on the graph. Okay. And then you connect to the y-axis, which is the voltage. So this is the value of V when I 0.8. So answer 1.1 volt. And we call this method as interpolation of graph. Okay. You are given one value on the graph to find another value on the other axis. So interpolation of graph, answer 1.1 volt. All right. Okay. So I think this will be our last question for tonight. Question 9. This is also SPM past year question. So you are given diagram shows an electric circuit. So you can see our battery there has an E.M.F of 2 volt with internal resistance of 1 ohm. This is the first switch. Okay. And there is a resistor of 5 ohm there. This is our second switch, S2, with an external resistor of 12 ohm there. All right. Okay. Then students, given the E.M.F of the cell 2 volt, as I mentioned, and internal resistance 1 ohm, find the reading of ammeter when only switch 1 is on. Okay. Second, when both switches S1 and S2 are on. Okay, so what is the reading of the ammeter? Okay, before that, this is all the given information. E.M.F 2 volt, internal resistance 1 ohm, resistance of R1 5 ohm, and the resistance of R2 12 ohm. Okay, so find the current when only S1 is on. So only S1 is on mean, okay, S1 on, so S2 is off. Alright, so this one close, this is open. So what is the reading of ammeter now, student, in this position? Okay, how to find them? Yeah, so when current, when we close S1, what happened? Current only flow through R1. Okay, it only flow through the first junction. Okay, it cannot flow through here because the circuit is incomplete. Okay, so how to find the current now? Using this equation again. So E.M.F is 2. Current we are looking for. This is the external resistance 5 ohm and the internal resistance of the battery 1. So now the current is 0.333 ampere. Alright. Okay. Next. So now both switches S1 and S2 are on. Okay. This one also we close. Close mean on, student. So circuit is complete. Alright. Okay. So what is the value of the ammeter reading now? Okay. So first you must find the effective resistance of these two resistors. So now they are in parallel. So the effective resistance is 3.529 ohm. Okay, from this calculation. Okay, 1 over 5 plus 1 over 12, and then you find the reciprocal. It will give you 3.529 ohm. Alright, so this is the effective resistance of these two resistors connected in parallel. Okay, now we apply the same equation. Okay, where E equal I R plus R. Alright, so E.M.F again 2 volt. Effective resistance calculated earlier 3.529. This is the internal resistance of the dry cell. So by this, the current flow 0.442 ampere. Okay, 0.442 ampere. So we can see that by the same value of E.M.F, 2 ohm. So you can see that when the effective resistance here is lower, okay, 3 compared to 5, the current flow in the circuit will be higher or greater, 0.442 ampere. Alright, okay, so I hope you are clear. Okay, this is another, I think this is our one last question, question 11. Okay. Now we have two diagram 1, diagram 2. Okay, here if you notice, we have two dry cell connected in series. Okay, here you can see there are 4 dry cell. Okay, connecting 2 dry cell in series and then connected in parallel. Right? So in total, here we are using 2 dry cell. Here we are using 4 dry cell. Okay, first, it say that switch S is closed and the internal resistance of the dry cell is 0.5 ohm. Alright. Before that, it mentioned up here, 2 dry cell. Diagram 1 show 2 dry cell 1.5 volt connected in series. Diagram 2 show 4 identical dry cell connected in series and parallel. So which means each cell has 1.5 volt E.M.F. Okay, first, A1. What is the total E.M.F supplied by the dry cell in both arrangement? Okay, so if you understand how we determine E.M.F, for diagram 1, it is in series, so 1.5 plus 1.5, it is 3 volt. Okay, so here for in parallel, up here we have 3 volt, down here also we have 3 volt, so the voltage is the same, also 3 volt. Okay, so both diagram has the same E.M.F of 3 volt. Alright. Okay, now find effective internal resistance in both diagram. Okay, so for diagram 1, how to find effective internal resistance for series, student. For series, so we plus we add. So 0.5 plus 0.5 give you 1 ohm. Or you can use multiply 2R. So 1 ohm. While for the parallel arrangement, how to find the effective resistance? Okay, so the effective resistance is 0.5 ohm. Okay, up here is 1, up here is 1. So we are using the 1 over R plus 1 over R. So we are getting 0.5 ohm as the effective internal resistance for diagram 2. Okay, then compare voltmeter reading, student. Compare voltmeter reading in V1 and V2. Okay, so how we compare voltmeter reading when the switch, for question B, we compare the voltmeter reading when the switch is closed. Okay, when the switch is closed. So when the switch is closed, so what happened? V2 will have higher reading compared to V1. Alright. Okay. Then ammeter reading. Okay, so what happened? A2 will have greater reading compared to A1. This is due to effective resistance in diagram 2 is lower from our calculation. So that's why ammeter reading in diagram 2 greater than ammeter reading in diagram 1. Okay, and then third, the brightness of the bulb. Okay, so what happened to the brightness of the bulb? Okay, since more current flow across in diagram 2, so diagram 2 will have greater brightness compared to diagram 1. Okay, so M2 greater than M1. Alright, so I think that's all for the discussion of exercises in E.M.F and internal resistance. So I hope you can cope and understand what I have discussed from the first learning standard until the fourth learning standard. Okay, so what do you think about tonight's lesson? Can you deal with them? Can you deal with E.M.F and internal resistance? I hope you will do well with E.M.F and internal resistance. So, and again, I hope this session will help you to understand this lesson in a better way. So, cikgu nak ucapkan banyak-banyak terima kasih kepada semua yang telah mengikuti kelas pada malam ini. Alhamdulillah kita telah habis topik ini 3.3. So jangan lupa untuk minggu hadapan Mr. P akan sambung untuk tajuk yang terakhir for the very last topic in chapter 3, 3.4 electrical energy and power. Bila siarannya hari Ahad, waktu yang sama 8.45 malam. Dan untuk kelas tingkatan 4, minggu depan kita akan sambung bersiaran dengan tajuk 3.1. Hukum kegravitian semesta Newton akan disampaikan oleh teacher SlindaNordin. Waktunya hari Jumaat 9.30 malam. Okay. So jangan lupa ikuti lagi kelas tuition percuma Fizik SPM di Akademi Youtuber setiap hari Jumaat dan hari Ahad. Jumaat 9.30 malam, kelas tingkatan 4 dan hari Ahad 8.45 malam, kelas DLP tingkatan 5. Okay, so again, thank you very much for your presence. Thank you very much for your commitment. I hope this session benefits to all who follow. Siapa juga yang tengok siaran ini, cikgu harap membantulah sedikit sebanyak. Jadi, cikgu mohon ampun dan maaf sekiranya ada tersalah kata ataupun tersalah bahasa. Sesungguhnya yang baik itu pada Allah, yang lemah itu daripada kelemahan dan kedangkalan ilmu saya. Semoga sesi ini memberi manfaat kepada semua yang mengikuti kelas pada malam ini. Jadi, sekian dulu daripada saya. Berjumpa lagi kita dalam kelas-kelas yang akan datang. Assalamualaikum warahmatullahi wabarakatuh.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini. Lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.akademiyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.